You can begin whenever you're ready.
Yeah. All right. Um, okay. All right. So I'm Ludus Panavis. I'm from Northeastern University. I'm a fourth year PhD student there from the Data Visualization Lab. And this past summer, I did the Open DP Fellowship where I started this project. And it's titled Developing a Visual Analysis Tool for Exploring Privacy Accuracy Trade-offs in Differential Privacy. So I said, started doing the interviews in the summer and got some kind of like general idea of what is required to do a differential privacy education tool. And now I'm continuing that work with Professor Cummings from Columbia and hoping over the next, I guess, spring semester to kind of make it those design requirements and interviews into an actual interface. And so first I wanted to talk about kind of like what's motivating this project. So there's questions when I was learning around about differential privacy that I couldn't find easy answers to when I was looking at documentation or textbooks. And it's these kind of trade-offs in accuracy. Like when should I choose one mechanism or one type of noise over another? And at certain points, depending on the inputs you put into the mechanisms, one mechanism should have a better accuracy than another, but it's not intuitive just by looking at proofs. And hopefully through some kind of interactive visualization, which here on example on the right, you can see the privacy or the accuracy of one noise type will be better than the other. Some other questions that a user might have would be like, what effect does changing the bound from 100 to 120 have on my accuracy? And you can do the math, but simply seeing it might be easier. And then for more advanced questions, like what are the impacts of using advanced composition methods on a privacy accuracy trade-off? So I think these are really hard to answer just by reading books or looking at the documentation. So our overall goal was to create a visual system to explore and simulate uh, differential privacy implementation choices on the accuracy of the output. And if you're familiar with the website DP Comp, they do something similar where they run many different differential privacy algorithms on different data sets, different sizes. Then they visualize these privacy accuracy trade-offs. And looking at the graphs that they put out, you can get a sense of what kind of algorithm is going to work best on what kind of data set. The same idea here is to look at what kind of mechanisms or noise would work best on your data set. And then over the summer, when I was presenting, a big question that was asked often was like, who will be the user? And we've talked about this as a group, and kind of what we put together as a user is a software engineer that recently joined to help on the data privacy team. So this is someone who has technical expertise. They know how to code, but they probably don't have any coursework or experience with differential privacy, and they kind of need to get up to speed pretty quick in order to be able to contribute to the projects. And hopefully, as an end result of having a system that simulates these different privacy accuracy trade-offs, people can go and will be able to release their own or do a differential privacy release from start to finish. And if given a new data set and problem, they should be able to set reasonable parameters. So by experimenting, they're able to find what would work for their different problems. So with that being the goal, we have three research objectives. The first is to understand the challenges individuals face when learning and implementing differential privacy. This is kind of the interview portion and what I was doing over the summer. And it's actually asking people like, okay, when you try to implement differential privacy or when you were on a team that had to do this, like what were the issues that you faced and how maybe they could be fixed. And then after we gather these user needs and preferences, how do we actually implement that into an interactive visualization system? So what kind of visual components do we need? What kind of explanations need to go in? And then finally is evaluating an interactive learning system on users' understanding of differential privacy. So to test whatever we build and see what worked, what didn't. Okay, so as we see, the current choices for learning around differential privacy, from my perspective, are kind of textbooks and blogs, which I don't knock. They're really excellent resources if you have the time and the patience to go through them. They will provide all the information you need generally, but if you're, for instance, a software engineer, you may not have time to read through a multi-hundred page textbook to actually get your answers or understanding. So you might need something quicker. And then on the other hand, from a more coding perspective, there's open source and there's the documentation. And in there, there are some visualizations that kind of show some privacy accuracy trade-offs. But to use the open source documentation, you need to download the libraries, you need to understand the libraries, and then you need to understand visuals and then implement them to actually simulate these different mechanisms impact on accuracy. So it's difficult from one or the other. And kind of what I propose or would like to do is create something that requires little to no coding and allows you to play around with the different choices. So here is an example I made of comparing Laplace and Gaussian noise and just changing a few of the input parameters like epsilon, the amount of queries, and the confidence level. And looking at that, you can see that, for instance, the amount of composed or joint queries most affects the decision to either use Laplace or Gaussian, and then same with the confidence level. But allowing someone to just mess around with the sliders rather than implementing a whole code block or reading through a textbook, they can get a more intuitive understanding of how which mechanism might be best or which choices might be best. So then over the summer, this is what I did at the OpenDP fellowship. Was my goal was to better understand these educational needs for differential privacy adoption and use. And I did a bunch of informal interviews, and then I got IRB approval and was able to complete 8 more formal interviews. And from there, I have 3 major design requirements that need to be put into a system to make it effective for the school. Here's some example of the questions that I asked. The first, well, this is 3, but there was a few more. But I was interested in what kind of challenges people encountered when learning about differential privacy and asked them to describe it. What questions they struggled to find answers to. So, like, what kind of parameters was there just not enough guidance on? And then also, what kind of resources or tools they used to learn about differential privacy. So, looking at what was effective, what kind of resources out there that are already effective, and how can I use that in whatever I create. And the interviewees came from, I grouped them into 3 categories. The first would be like a data scientist at a public agency. So someone who's proficient, technically proficient, but may not have a lot of differential privacy experience and needed or joined a team or had to implement differential privacy. And in the future, this is more of the group I will be targeting. Student, so any of the OpenDP fellows is a pretty good example of people who may not have a ton of experience but are learning about differential privacy, may need to apply it to some real world problem. And then finally is more of a social scientist who they don't know much about privacy, may not be as technically proficient, do as much coding. So they just need to know the bare bones or the basics. All right, and then I have 3 design requirements, as I said. The first was you need to provide explanations of differential privacy implementation parameters. And like here was a visual I made of 2 Laplace distributions as I was trying to think of a better way to elaborate on this common visualization. And some of the quotes that interviewees said, kind of paraphrasing, but they found the terminology confusing. They maybe knew the definition, but not to how to actually apply how it applies to what they're doing. A couple people said that there were so many terms that it was kind of hard to keep track of everything, and they wanted a glossary of terms. Some of the parameters that they found confusing, for instance, was sensitivity, because it's used in many different, or it's used a lot, but sometimes it can mean different things. There's like L1 sensitivity, L2 sensitivity. And then privacy unit. So the people who had to implement real world problems, they had to set user level privacy or like event level privacy, and deciding what how to do that and what that actually meant wasn't particularly well documented. The second design requirement, and kind of the basis of this project, is to provide an exploration of parameters on the privacy and accuracy. So changing parameters, seeing how that changes the accuracy. Here's like, again, a little interactive visualization of Laplace and Gaussian and how changing the epsilon changes the accuracy. So yeah, as I said, in which context is it better to use Gaussian noise instead of Laplace noise? People wanted to kind of show the trade-offs, and they were asking, is there like an optimal point, or is there, when should I choose one or the other? Is there a set criteria? And that there was a difference between concept and internalization. I think this is where more interactive visualizations would really assist. You can read the math definitions, you can understand what sensitivity maybe is, but playing around, messing around with the system that allows you to explore the parameters would allow you to internalize these concepts.
Hey,
Um,
Ludas,
yeah,
um, are you taking questions in between, or do you want us to save them
go
for the?
ahead. Yeah, seems
I
like a
had a
small
question.
group.
I had a question about the last slide.
Yeah,
So like on this demo on the left, like the right-hand side part of it, I'm curious if you could explain like what that represents and why you have like two versions of, yeah, just what the right-hand side part represents.
this here,
Yeah.
or I don't know if you see my mouse. Yeah, so this is not fun, but it is something I was like working on in our prototype. But it was like the potential outputs if you release it privately, because it's a probabilistic function. So I was showing like I sampled 50 potential um, private outputs on a certain query, and then that kind of it's trying to show what that line means. So if you have like a error of 30 versus like an error of 10, it increases in it's not the full image as well.
So like I mean, these are sort of hypothetical draws or something from
Yeah,
the output mechanism.
right.
Um, w like what axis should I be reading it off of? Like what is
Uh,
that?
it's a great question. So the full thing is like a bar, like a count, I guess, and the red would be the real value, and then the blue would be possible private outputs. But there's not, I guess, really an axis for the blue lines. I was just trying to, instead of just seeing a line, I wanted to show what the actual query output would look like. Like what does that size of error look like in comparison to the real value? Does that answer the question at all? You can have more follow-ups.
Yeah, but I think maybe we can chat offline because I think I'm still a little confused about um like how to actually interpret one of those lines. But I think I get the general concept. So thanks.
Right. Yeah. Yeah, definitely. I would love also your input on some of these visualizations. And they're a work in progress. I was just trying to sample some of the, I guess, prototypes that I made. So it wouldn't just be generic visuals off Google. Okay, I'll go on, then always hit me up offline. And then the third design requirement is to provide real world context. And this is just a front end to a back end that I made to test how quickly you can get answers from like the OpenDP library to a front end using JavaScript. And that's a problem that I'll talk about later, that there is lag, and therefore you kind of have to implement stuff in JavaScript that's already implemented in Python. But one participant said, I don't, they don't want to see proofs, but instead they want to see how it actually applies to real world problems. A lot of people need some kind of real world example, for instance, students in a classroom with grades, to understand what these different choices, like what are bounds, mean. And then also that real data can be very tricky. So for instance, like an income data set can have really big outliers. So correctly setting the bounds makes a big difference there. Okay, so yeah, the 3 design requirements, you need to provide some kind of explanation of the parameters because not everyone is familiar with them. Give an exploration of privacy accuracy trade-offs with different inputs, and then provide some kind of real world context so people can ground these simulations into real data release. And we made a prototype, it's very bare bones, but it was just to investigate some of these concepts and try to put the design requirements in practice. And it allows you to test different basic functions like count, sum, mean on 2 different noise types, Laplace and Gaussian. And from that, I have 2 major challenges that I'm facing with implementing it and deciding how to go forward with the prototype. The first is user knowledge. So there is kind of a pretty big spectrum of people's experience with differential privacy and then even background experience with technical skills. From a novice to an expert. So someone who's a novice or like has no differential privacy experience, like you can't assume that they know anything about epsilon or any of the input parameters. And then the people we're kind of targeting is someone who's maybe has a little bit of knowledge or like understands what epsilon is, understands what bounds are, but doesn't understand how that exactly applies to the accuracy when releasing. And in that sense, there's also very different ways to explain differential privacy, from the mathematical proofs to really simple visualizations. And as I've been working on the interface, a lot of it sometimes it requires a lot more text than I would expect. So if you create a visualization, you have to make it intuitive or explain what's going on, as was just seen. And having an interface that has too much text versus actual visuals can make it maybe overwhelming or not useful, and people have to read a lot. So deciding on how much explanations to give and what kind of explanations has been a challenge. And then the second challenge is the scripting language. So a lot of privacy, or most of the privacy implementations, are in Python, for instance, OpenDP, and all the proofs, and like that all those work are there in the Python world, but visualization and user experience and my own kind of coding background comes from front-end web development. So having to develop an interface that does not have that kind of formal privacy packages ready has been challenging, and sometimes I think translating the different formulas may cause errors or may be incorrect. So I want to make sure that if we are simulating anything, that what we are simulating is true. So then moving forward to overcome these kind of 2 challenges is I want to continue interviewing people with more of a focus on that target user of a software engineer, and then also improve the prototype to the point where it can have user testing. So yeah, the future interviews, I'm going to have a target group of the industry data scientists or software engineers who have had to work with differential privacy, but then also people who are actually on these privacy teams that have had to onboard other individuals. I think they can give insights into what works and what doesn't. And for the interface, right now, it was really the simplest of choices, like the count, sum, mean, and 2 different noise mechanisms. But I want to expand that. I want to also help link it to real world context. Right now, there's not much of that. And then look into using a framework like Django. So it's a website built off of Python, which might help with getting all those privacy formulas, mechanism, algorithms in without having to connect a front end to a back end. Okay, and then I have some questions that I would like to ask in the next stages of interviews, and if there's anyone or any feedback on them, I'd love to hear that. So the first set of interviewees, as I said, was the software engineers. And I have 4 kind of questions that I'd like to ask. The first one is to better understand how much they know about parameters, how much explanation do we need to provide versus and guidance, or how much can we assume that they already know? And it's like, can you independently set differential privacy parameters like bounds and mechanisms, or do you require explanations? How do you and contextual understanding for these tasks? So do they need to understand what a bound is, what sensitivities are, and how much do you actually need to write about that? Then I want to know the importance of simulating or trying out different choices on, for instance, like a public data set. So seeing the effects on something that is more tangible, like a real data set. Then how do they evaluate utility of their data release? Are there different accuracy metrics that they might use? And then do they use any composition methods beyond like basic or advanced? What kind of composition methods do you use so we can include those? And then for the other set of people who would like to interview, the privacy team leads, I'd like to know kind of what kind of challenges new team members have had. So hopefully we can address those. Also get their kind of vision or see if they have any ideas on how a visualization tool could aid them in training new people as they join the team. Then, similar to the other one, like what criteria guide your choice of DP mechanisms, and how do they balance privacy and accuracy? So what kind of goes through their head as they're releasing a data set privately, and then same as the other one, trying to get a better understanding of how much people or background knowledge we need to provide in the system, so people can use it and mess around with the inputs. And yeah, that is all for the presentation. Would love to discuss if there's any suggestions on target user group or user interface, the scope, future interview questions, or if people just had interview questions they would like to ask practitioners, I would love to hear them so that we could have a good list or a good set of interviews after the new year. And yeah, thanks for listening.
Does anybody have any questions or comments? It looks like there's some, I don't know, can you see the chat?
Yeah, I can. Besides the challenge of using differential privacy, I also think that there is a challenge of convincing people that their data will be private. How do you show, measure, prove the privacy of their differential privacy data? And how do you recommend the best epsilon for their particular data set? So we've talked about this as a group, and um, since it's hard to like measure privacy of a data set except for the level of epsilon you set, our goal is to try to show the choices with the best accuracy. And then you should set, for instance, some kind of accuracy measure and then try to minimize your epsilon as much as you can. So instead of trying to set your epsilon right away, you should maybe set a criteria for your accuracy. And then the goal should be to minimize or like have the lowest possible epsilon. And I agree that there is a challenge of convincing people that their data will be private. At one point in the summer, I was going to switch to that, like trying to show privacy risk or like why you should use differential privacy, um, which I think is difficult to like prove that people's data can be attacked and convince them, but I don't have any answers for that. And I think that answers, yeah, we don't really have a way to show privacy aside from like, I haven't really, like, this is your epsilon. You're welcome.
Any other questions?
Good then. Friday early.
Another question from Anna.
Which queries does your tool support? So right now, I just have implemented like count, sum, mean, histogram, which is the basic ones. And then you mentioned also the time process. So when I meant time processing the data, so if you want to create a visualization like a line chart, you need to if you're doing it maybe on like a real data set, you need to send many queries to get the whole scope of the line. And the size of the data set, I haven't really, the only one I've tried is the California demographic one, which is around 1,000 people. And it took, I mean, it didn't take long to get like a singular query, but it doesn't give you like a full distribution back. So if you wanted a full distribution, it would take longer because you have to send many queries. Priyanka?
Yeah, I had a question about like your target audience. You mentioned that you're envisioning someone who has some knowledge of like a scripting language, but perhaps not deep differential privacy expertise. And I'm curious, like, how do you envision your tool sort of leveraging the user's scripting knowledge? And I guess along these lines, I wonder if you've thought about modules where someone could be, in a Python like Jupyter Notebook, and then a version of this interface, they can like quickly code up a version of this interface, like call a little environment, and then the visualizations pop up or something. Anyways, just in general, your thoughts on the scripting
Yeah.
knowledge aspect is really interesting to me.
Definitely have thought in the past about making some kind of like visual library that works on top of some of these choices so you could put it in. My goal for this interface ideally is like you could have a button that allows you to download the Python code with the parameter choices. So I mean, like using an OpenDP library or can be difficult for a first time user. So setting the parameters in some kind of interface and then downloading the like Jupyter Notebook block to run in your own environment could be a good way to like take like setting, I don't know, take some of the ease off of actually implementing differential privacy. Yeah, open to more suggestions.
Anybody else have any comments or questions before we wrap up the discussion? Sounds great. Thanks so much for presenting today, Ludus. I know a lot of people are really excited about your work, so it's nice to see the progress over the time since you've been working with OpenDP. I know a lot of people will be looking forward to watching the recording of your presentation, so I'll be sure to share that with them. And I think you snuck in the last presentation of 2023, so it's a great way to end the week and a great way to end the year.
Yep, thank you. Thank you for letting me talk.
Yeah. All right. If nobody has anything else, that'll be it for today. It's good to see everyone. Hopefully we see you guys again soon at one of our upcoming meetings. Okay, take care. Have a good weekend.